Last presentation, we saw pointer to pointers, which is something like a higher dimensional pointer that stores an address of an address. In this presentation, we'll see multidimensional arrays. The idea behind multidimensional arrays is arrays of arrays. A common example of a multidimensional array is a matrix in mathematics, which is like a two-dimensional array. We'll see how to declare multidimensional arrays, in particular two-dimensional. We'll see how to use them, and we'll also see how to draw memory diagrams with multidimensional arrays. This presentation follows section 14 in your workbook, and it begins with 14.1, declaring multidimensional arrays. You've seen how to declare one-dimensional arrays using square brackets. Inside the square brackets is the number of elements that you want for that array. If you leave the square brackets empty, then you must initialize the array with the given number of elements. In that case, with empty square brackets and an initialization statement, the array will have just enough space to store the number of elements you initialize it with. Multidimensional arrays follow the same idea. If you want a two-dimensional array like a matrix, you'll use two sets of square brackets. When you declare a multidimensional array, just like a one-dimensional array, the first set of square brackets can be empty. In that case, it will automatically adjust the size to fit how many you initialize it with. However, the second set of square brackets must be given a size. In the example, I declare a matrix of doubles, which has an unspecified number of rows, but has two columns. The number of rows is determined by the initialization statement, which has 3 sets of rows, so the matrix will have size 3 by 2. As I put in the comment, you could also explicitly write the 3 instead of leaving the square brackets empty at the start. Now try to guess what the output of each printf statement will be. Remember that the square brackets have higher precedence than the dereference operator, but the parentheses have highest precedence overall. Let's look at each output statement one by one. The first one, matrix 2, 1, uses the index 2 to index the row. So matrix square bracket 2 takes us to the row that's initialized with 9.0, 0.0. And then the second index indexes the column, or the element within the row. And the second index is a 1, which takes us to the second element in that row, which is 0.0. In the next line, we have to remember that square brackets happen before dereference. So matrix 1 takes us to the second row, which is 5.6, 7.8, and then dereference gets the value at that address, which is 5.6, or the first element. In the next line, the first thing that happens is again matrix index at 1, which is the row 5.6, 7.8. Now the type of matrix 1 is a pointer to a double. You can think of the type of matrix as pointer to double. So matrix 1 removes one level, and we're left with a pointer to double. So when we have plus 1, that's doing pointer arithmetic on a type pointer to double. So it will advance us one double ahead. So currently we point to 5.6, and then the plus 1 advances us to point to 7.8. And finally we dereference to get the value 7.8 at that address. In the last line, we're doing pointer arithmetic on matrix. And matrix you can think of as a pointer to pointer, or a pointer to a row. So when we have matrix plus 2, that advances us 2 rows ahead. So we end up pointing at the row 9.0, 0.0. And then the 2 indexing of 0, 0 takes us to the element at that location, which is 9. These can get a bit tricky, so as you evaluate each expression, remember what the current type is at each step. Here's the memory diagram for the last example at point 1. It gets laid out in memory just like a normal array, except now you have to remember that the entire row's elements get allocated before the next rows. So you'll see that the first row, 1.2, 3.4, are allocated first, and then the next row, and then the last row. As we saw, a matrix is a very common example of where multidimensional arrays are used. Section 14.2 asks you to write an application using multidimensional arrays, and it is a matrix in this case. The idea is to write pseudocode and then C code for a function which reads a matrix from a file, calculates the average of each row, as well as the average of the entire matrix. And lastly, it writes the averages of each row and the total average to a file. So please take a few minutes and try your best to complete that exercise. I'm going to go over my solution in 3 parts. First input, then the calculation, and I'll finish with the output. So beginning with the input, here's my pseudocode. And remember that pseudocode can vary widely, so anything that effectively describes the algorithm will be good enough, whether it's close to English or close to code. My solution is fairly close to code. It begins by opening the input file and then reading the first 2 entries in the file, which specify number of rows and number of columns. In my pseudocode, that less than followed by a dash or a reverse arrow means that that value on the right gets assigned to the variable on the left. After that, there's a 2-level repetition structure. The outer loop reads through each row, and the inner loop reads through each column. Those entries are directly stored into the matrix. And lastly, at step 4, I close the input file because we're done reading all the elements. Here's what that looks like converted into C code. This code is available online in the Code Developed in Spring 2003 section of Blackboard. Because it's a C program, all of the declarations are at the top of the block. So the matrix is declared as a 2-dimensional matrix of max size by max size. And max size is a defined statement which gets converted into the number 10. That was given in the question. And then I declare 2 files, input and output file, and then all the bookkeeping or the index tracking ones like numRows, numCols, and then all the ones used for calculating the averages. The following statements are very similar to the pseudocode I developed, except that now we're using C, so we should check that the file was successfully opened, and that's what the test for inFile equal to null is doing. The integers specifying numRows and numColumns are read using fscanf just before the for loop, and then the body of the double for loop is just reading one element of the matrix at a time. And now I developed the pseudocode for the calculation portion. It begins by initializing a total to 0, and then starts a loop which goes through each row. And for each row we have to calculate the average of the row, so then each time we go through that loop, row sum gets initialized to 0. And then the inner loop, which goes through each column, simply adds up the row sum. Once the inner loop completes, the average of the row is calculated as row sum divided by numCols, or number of columns. And finally, the total is incremented by the sum of the row. My pseudocode is close to C, and each line gets directly translated into C code. And here's what I came up with for output pseudocode. Open the output file, then go through each row, and at each row output the average that we calculated in the previous step. That's row average. And then to finish up, output the average overall, which is calculated as total divided by numRows times numColumns. And finally, close the output file. This is again almost directly converted into C code, except we added a check to make sure the file could be opened. and the output is specified using a 8.3, which says the width is 8 and there should be 3 digits after each decimal. That was a specification in the problem. And now we'll wrap up our study of multidimensional arrays by looking at how to pass multidimensional arrays between functions. In this small example, I've extracted out the portion of the previous application to calculate the total average. In the main, we declare a matrix which is 3 rows by 2 columns, and we print out the overall average, which calls the function average with m and 3, where 3 is the number of rows. If you look at the first line of the definition of average, you'll see that the first argument is double m, empty square brackets, and then square brackets with a 2. That's exactly the same way that we declared m inside of the main function. So the same rule follows that the first set of square brackets can be empty, but all following ones must be specified. You could specify the first one in the argument, but as we saw when we studied passing arrays, if you specify the first dimension, it is ignored. Because all dimensions except for the first one must be specified, it can be useful to have a define statement. In this example, I define numCalls to be 2. That way, when you go to change the number of columns, you only have to change it in one place, and it also makes the code easier to read. In this presentation, we saw how to index multidimensional arrays using a variety of techniques, including pointer arithmetic and dereferencing, as well as square brackets. We also saw what multidimensional arrays look like in memory diagrams, which is very similar to a normal array. You just need to remember that the entire row gets allocated before moving on to the next row. And we finished off by seeing how to pass multidimensional arrays between functions. In doing so, you have to remember that the first dimension can be unspecified, but all following dimensions must be specified.